As you can see here, is comprised of two lobes. So there are two lobes. Each lobe, as you can see, is compartmentalized into individual lobules by connective tissue that separates and surrounds these. And there is a small, narrow tissue piece that connects it, known as the isthmus. So we have that anatomy. You'll notice it is basically located just below the larynx. Here is our larynx. As we'll talk about, it plays a role in regulating the movement of food and drink into our esophagus and air into our trachea. This large plate-like piece with the prominence that forms your Adam's apple is known as the thyroid cartilage, because basically it sits right above the thyroid gland. Now notice they've removed half of the thyroid gland here so that we could see the trachea, but here you see nicely a little bit of the isthmus and one of those big lobes of the thyroid gland that is sitting here. One of the nice things about the histology from these is, for the most part, most of our endocrine glands look very different from all of the others. There we go. We'll do the drawing first. When we look at the thyroid gland histologically, what you are going to see, is it there? That should be there. Did we jump some things? Yeah, we did. Okay, perfect. That's what I wanted. All right. If you look at the thyroid gland is made up of a bunch of fluid-filled follicles. All right. Here we have a simple cuboidal epithelial tissue. These are the follicular cells. And they surround this fluid-filled or colloid filled space. What is a colloid? I don't know either, so don't worry about it. No, colloid is basically when stuff is suspended in water. It's not dissolved in it, but it's suspended in it. And basically, what is suspended within this water is a massive amount of our thyroid hormones. In these follicles, you store about a month's worth of your thyroid hormones. That sounds like a lot, because it is. Do you think we store a month's worth of prolactin or oxytocin or even antidiuretic hormone in our pituitary gland? No. So that must mean that these thyroid hormones are super, super important. And they indeed are. This follicle and these follicular cells are the ones that produce the class of hormones that we call the thyroid hormones. And, as we also mentioned, there are two specific ones. They are T3 and T4. However, are you going to get away with that on the exam? No, absolutely not. Triiodine, iodothyronine, and thyroxine. And again, they contain iodine. T4 has 4 iodines, and T3 has 3 iodines. Yes? Yep. Exactly. Our thyroid hormones are very unique. Your book actually does an amazing job of describing the process of how they're made by the follicular cells, how they're stored in this colloid, and how they're released. And do you think I'm going to hold you responsible for that information? Can we talk about it? No, not yet. And we're not going to. If you're interested in knowledge for knowledge's sake, thyroid hormones are very interesting hormones. And one of the very unique things about them is that they are, though they're amino acid based, they are lipid soluble. So they actually do have their effect by entering into the cell. So they're very unique, very interesting, but we're not going to get into depth in the production and the storage and the release or any of those things about them. All right? What we are going to talk about, though, is what they do. Not surprisingly, they're massively important, and that is because they pretty much target most of the cells of our body. In fact, I believe there's at least one, and there might be more groups that are actually looking at problems with the thyroid gland. Right? These glands produce our thyroid hormones that affect most of the cells of the body, basically playing a huge role in setting our basic metabolism, but also affecting things like blood pressure and body temperature. If you don't produce enough of this hormone, what do they call that condition? Hypothyroidism. These individuals have a difficult time thriving. They're typically very small in stature, thin in musculature. They fatigue very rapidly. They have very low energy levels. Conversely, if you produce too much of this, what condition is that? Hyperthyroidism. Right? Apparently I'm ready to be done too. Hyperthyroidism can cause the metabolism of the cells to be so active that actually your bones continue to grow and your growth plates never close. The metabolism of your bones are so rapid that your growth plates never close. All of the people who have ever been the tallest people in the Guinness Book of World Records are all individuals who have suffered from hyperthyroidism, where they continue to get taller and longer their entire lives because their growth plates never close because of the overall metabolism. Back in ancient times, and by ancient times I mean the 90s, there was a basketball player, a mysterious, mystical basketball player who came out of China called Yao Ming. Right? Yao Ming was one of the tallest human beings on the face of the planet. And when the NBA paid an exorbitant amount of money to get him from the Chinese national basketball team so that he could play over here in the NBA, and they refused to release his medical information. And so there was a tremendous amount of speculation at the time that he might have been somebody who suffered from hyperthyroidism and then had his thyroid gland removed, which is why he stopped growing taller as a result of that. So it has huge, major impacts on the function of the body. All right? Questions on that? Yeah.
What's the difference between the lobes and lobules?
So the entire structures, those are the lobes. So you have two lobes. Each lobe has connective tissues that compartmentalize it into smaller subunits. And each of these smaller subunits would be the lobules. Yeah, lobules are the small compartmentalized pieces that collectively make up the lobes. And how are our thyroid hormones regulated? There you go. Exactly. So that would be hormonally via thyroid stimulating hormone. Exactly. All right. Oh, I keep pointing it that way. So notice here we see a lot of follicles. We see a lot of that colloid filling those follicles. But notice to the side, in between the follicles, are clusters of little cells. lighter colored cells here, right? Some of the lighter colored cells here. These cells next to, alongside of the follicles are what are known as parafollicular cells. These parafollicular cells are not part of the follicle and don't make thyroid hormones. Right? Thyroid hormones are hugely important, as we talked about. As we mentioned, we talked about hypothyroidism, hypo and hyperthyroidism. One of the things that used to happen in certain parts of the country was you get people who would have these massive goiters that would form, right? Because it was constantly being stimulated by our thyroid stimulating hormone, trying to cause it to grow, trying to make more of these hormones, but we couldn't make those hormones. And why couldn't those people make those hormones? Yeah, they lived in areas where the water or the soil didn't have iodine in. Right? Iodine was vital for the production. So how have they resolved this? They moved everybody to the places where the iodine was? Yeah, the iodized salt, absolutely. Because we pretty much put salt in everything, and it is pretty much impossible to buy salt these days that isn't iodized, right? So, I mean, there's some like sea salts and yeah, stuff like that, some fancy ones that you can get. But most salts now are iodized just to make sure that everybody's getting the iodine that they need. Hugely important. But that's not what these parafollicular cells do. These parafollicular cells produce a very different type of hormone with a very different effect. And that hormone is one you guys mentioned earlier, calcitonin. Calcitonin, as we talked about, plays a role in regulating our calcium levels in our blood. It targets osteoclasts, telling them to do what? Break down bone. It targets the kidney, telling the kidney to do what? Yeah, reabsorb more calcium. And it triggers production of another hormone, calcitriol. Why does calcitriol sound familiar? What is that the active form of? Vitamin D. And what does calcitriol do? Yeah, small intestine and our digestive system, stomach, small intestine, tells them to absorb calcium from our food. And of course, where is that vitamin D formed? Skin. So our three targets would be the osteoclast, kidney, and the skin. Collectively, we could talk about the individual effects, but collectively, their goal is to increase calcium levels in the blood. And that would be fine to write as a function. Yes?
On this slide, why does it say inhibits osteoclasts?
Oh, I'm sorry, you're right. God, I got it backwards. I was talking about parathyroid hormone. You are correct. It decreases, it inhibits. I really am done for the day, apparently. It targets the kidney to not reabsorb calcium, to let it go into the and let citriol production. So the overall effect of all of this is to do what?
Decrease.
Yeah, bring calcium down, sorry. Should have quit when I was ahead. But we didn't, we pushed forward. Alright. Notice, one of the issues of this, again, is it helps us to play a huge role in regulating calcium levels. So we talked about if people have thyroid cancer, or if they have hyperthyroidism, one of the things they'll do is remove the thyroid. And if they remove that thyroid, yes, we remove all that excess T3 and T4 that they're making, but does that also affect their ability to be able to regulate calcium levels? Yes, they have to be much more careful about their calcium intake as a result of that. All right, so again, these are produced by the parafollicular cells, and how do you think calcitonin levels are regulated? Say again? Hormonally? What hormone would do it then? Humorally. By what? Calcium. Excellent. It's measuring the calcium levels in the blood. If calcium levels go too high, then our thyroid gland releases calcitonin to bring those calcium levels down. So it's regulated humorally by calcium levels. All right. And then again, there we see that parafollicular cell producing the calcitonin. Now, the same way we want to bring calcium levels down, we also want to bring